This video provides an introduction to the sine law. So let's first look at a quick demonstration. So here we have a triangle. It has some angles that are labeled and some side lengths that are labeled. You can see here. And we're just going to look at some of this information. First, if angle A is up here, just a reminder that side length A is located at the opposite end of the triangle. We typically use capital letters for angles and lowercase letters for side lengths. So if angle B is over here, side length B will be on this side. If angle C is here, then side length C will be over here. So what I want to do is look at the ratio of sine A divided by A to start. So if we take the sine of angle A, so the sine of 54.6, you should get, if you did that on your calculator, you should get 0.815. If we then divide that by the length of side A, which is 7.99, you should get 0.102. And notice here that the same thing is true if we do this for B and C. So take the sine of 32.7, divide it by the length of B, which is 5.3, should get 0.102, and do the same thing for C. Sine of C, here's C here at 92.7, divide that by 9.8, and we get 0.102. It's not an accident that all three of these ratios are identical. And in fact, that's really what the sine law is all about. So if we start dragging some of these angles around, you can see that the angles are different. Get some of this out of the way. The angles are different, but the ratios are still equal. No matter what kind of triangle I draw, how I draw it, those ratios stay the same. So that's basically what the sine law is all about. So let's have a look here. We just saw this part right here. We saw that no matter what happened as we change the angles in the triangle, that the sine of an angle divided by the length was equal, sorry, the length of the corresponding side was equal for all sets of angles in the corresponding sides. We can actually flip that ratio upside down, these ratios upside down as well, and still have it true. So the side length over the sine of the angle is equal for all of those angles. Typically, we want to make sure that the unknown value is in the numerator, so you choose the appropriate one. Let's look at an example. So here we go, example, our first example. We want to find a measure of angle C. So here's angle C. Let's label the triangle. So if angle C is here, side length C is at the opposite end of the triangle. Here's A, so side length A is here. We have angle B, so side length B is over here. We want to find angle C. Now, in order for the sine law to work, we need to have a pair of angle and corresponding sides. So in this case, we have 62 degrees, and we have its corresponding side length. So we have that sort of one pair so that we'll be able to fill in the values in the equation. The other part that we need is, in this case, I'm given a side length, we're given a side length, and we're asked to find the corresponding angle. So the piece of information that we're trying to find, we need to have the other corresponding piece of information. If I were given angle C and I were trying to find side length C, that would work. And we'll do that in a moment. All right, so let's get going here. We have information about A. We're trying to find information about C. So let's set up the equation using the sine law. So the sine law says that sine A over A equals, and because we're trying to find information about C, I'm going to use this one right here. Now we can plug in the values. We know that angle A is 62 degrees. Side length A is 10 centimeters. We don't know what angle C is, so I'm going to leave that. But we do know that side length C is 9 centimeters. This is now an equation. We can solve this equation. I'm going to break this down bit by bit. Some of you might just be able to quickly go, oh, well, sine of 62 divided by 10 and get a response. But I'll break it down into little pieces here. So the sine of 62 is 0.8829. That's the only thing I did. And again, we can do this division. 0.8829 divided by 10 works out to about 0.088, and I'm just going to round to a 3. 4 decimal places would be lots. I lost a 9 up here. So the only thing I did in that step was do the division here on the left side to get this. So we're getting close. Remember, our goal is to find C. Right now, the sine of C is being divided by 9. We want to get C all by itself, so we need to undo this division by 9. How do we undo a division by 9? Well, we do the inverse operation, which is multiplication by 9. If we multiply one side of the equation by 9, we need to multiply the other side of the equation by 9. This 9 divided by 9 here is just 1 on the right, so that leaves us with sine C. And then 9 times 0.0883 works out to 0.7947. Again, just make sure your calculator's in degrees. If not, you might have some numbers that are different here. Because our angles were measured in degrees, if your calculator's not in degree mode, you'll get some weird answers. All right, we're close. We're trying to find C. It's right here. We need to undo this sign. I'm going to write this out. It looks kind of cumbersome, but I want to write it out so you can see it. I imagine that you may not need to, but we need to undo the sign operating on C. And the way that we undo sign is with the inverse sign. So the inverse sign shows up like this. You'll need your calculator for it eventually, and most of you, to get to that on your calculator, will have to press something like a second and then sign, or a shift and then sign. But we'll get there in a moment. So the inverse sign will undo sign, leaving us with just C on the right. Now, if we apply the inverse sign to the right side of the equation, we need to do the exact same thing on the left side of the equation. So we do the inverse sign of 0.7947, and we get approximately 52.6. And I'm just going to round that. In fact, when we do this, we can, when we're talking about the angles, the nearest degree is acceptable. All right, so we just found that C, angle C, is 53 degrees, which is what we were asked to find. We now have two angles in the triangle. You can probably remember how to find the third one. We weren't asked to yet, but we're going to find it anyway. Angle B is up here. Remember that all of the angles in a triangle have to add to 180. So B has to be 180 minus the 62 that we have here, and minus the 53 that we have over here. And when we do that, we get that angle B is equal to 65 degrees. So the only piece of information that we're missing in this triangle now is side length B, and that's what we're going to find next. So our second example is all about finding side length B. So here's the exact same triangle, all drawn out, but now we're going to find a side length instead of an angle. Again, we have this angle and side length pair. We're trying to find this side length here, B, and we have its corresponding angle. So that sort of setup of angle and corresponding side is in place. We want to find a side length this time. We could, by the way, we could use C. We could use this information. I generally don't like to use a calculated. We calculated this, remember? I generally don't like to use a calculated number in calculation, just in case we messed up on that 53 degrees. Our answer is going to be wrong again. But it should work and come fairly close. All right, so we're trying to find a side length. So we're going to put the side lengths in the numerator. So we'll have A over sine A. And because we're trying to find information about B, we're going to use B over sine B. Again, plug in all of the information that we have. We know that side length A is 10. This angle A is 62 degrees. We don't know side length B, but we know that angle B is 65 degrees, which we just calculated. Again, we have an equation here, one unknown value. Let's do 10 divided by sine 62. Let's figure this part out. 10 divided by sine 62. That works out to 11.33. Haven't changed anything on the right. We want to figure out what B is. We can do that two ways. We can actually figure out what sine 65 is as a number and then multiply by that number. Or we can say, hey, B is being divided by sine 65. How do we undo a division by sine 65? Well, we do the inverse operation, which is multiplication by sine 65. And if we multiply on the right by sine 65, we better do the same thing on the left. So the two sine 65s here will divide out, leaving us with 1. And then we get B equals, when we work this out, sine 65 times 11.33, we should get 10.3. So we just found here that B is approximately 10.3 centimeters. And that, in a nutshell, is the sine law. So sine law to find an angle, and the sine law to find a side length.